Have you ever pondered what could happen if space and time started to collapse? A rather disconcerting thought, isn't it? Welcome to the enigma of space and time, a concept that has baffled the greatest minds throughout history and continues to do so today. In the realm of physics, space and time are interwoven into a single continuum known as space-time, a concept that emerged from the brilliant mind of Albert Einstein. With his groundbreaking theory of relativity, Einstein revolutionized our understanding of these fundamental aspects of reality. He proposed that space is not a static stage on which events unfold, but rather it's dynamic, bending and warping under the influence of mass and energy. Similarly, he postulated that time is not a constant river flowing at the same rate for all, but it can slow down or speed up depending on the observer's speed and gravitational field. This radical view of the universe was a significant departure from the classical Newtonian physics, which held space and time as absolute and separate entities. It opened up a new realm of possibilities and mysteries, challenging our perception of reality. Now let's take this a step further. What if this space-time continuum, the very fabric of our reality, started to collapse? This isn't just a plot for a science fiction novel, but a legitimate question that physicists grapple with. The collapse of space and time can have profound implications, from the breakdown of the laws of physics to the end of the universe as we know it. But before you start panicking, let's remember that this is purely theoretical. We don't have any empirical evidence to suggest that space-time is collapsing, at least not yet. Nevertheless, exploring such extreme scenarios can lead to new insights and push the boundaries of our understanding. Now, hold on to your seats as we dive into the fascinating world of collapsing space and time. Let's embark on this journey together, exploring the unknown and challenging our perceptions of the universe. It's going to be a wild ride, so buckle up. To comprehend the collapse of space and time, we first must grasp what they are. These two fundamental aspects of our universe are interwoven into a four-dimensional structure known as space-time, a concept that is as fascinating as it is complex. Imagine space as a vast, limitless expanse that extends in all directions. It's the stage where all matter exists and where all events take place. Now imagine time as a river flowing endlessly, carrying along everything in its current. It's the dimension that gives order to the happenings of the universe, dictating what comes before, what happens now, and what will follow. Now, picture these two concepts merging into one, a four-dimensional fabric that weaves the universe together. This is space-time, a concept first introduced by Albert Einstein in his theory of relativity. According to this theory, space is not a flat, static stage, but rather it's curved by the objects within it. The more massive the object, the greater the curvature of space around it. This is what gives us the force we perceive as gravity. And what about time? Well, time is also influenced by gravity. Einstein's theory also predicts that time can slow down in areas of high gravity. This phenomenon, known as time dilation, has been tested and confirmed by scientists. If you were to spend time near a black hole, for instance, you would age slower than someone far away from the black hole's immense gravitational pull. While these concepts might seem abstract and distant, they are integral to our understanding of the universe. Every movement we make, every moment that passes, is governed by the principles of space and time. Now that we've wrapped our heads around space and time, let's explore what it means for them to collapse. The collapse of space and time is a concept that tickles the imagination and bewilders the mind. Imagine a universe where the very fabric of reality starts to crumble, where the principles that govern our existence start to fail. This isn't a plot from a science fiction novel, but a possibility proposed by cosmologists and physicists when they speak of the collapse of space and time. What would happen if space and time started to collapse? The most popular theory is the Big Crunch. Picture the universe as a massive balloon, expanding since the Big Bang. But what if, instead of expanding indefinitely, the balloon starts to deflate, to shrink back in on itself? This is the essence of the Big Crunch theory. The universe, after expanding for billions of years, would begin to contract, eventually collapsing in on itself. But what does this mean for space and time? As the universe contracts, the fabric of space-time would also contract, becoming denser and denser until all matter, all energy, all space, and all time are compressed into an infinitesimally small point. This point, known as a singularity, is where our understanding of the laws of physics break down. It's a state of infinite density where space and time as we know them cease to exist. This collapse of space and time wouldn't be an instantaneous event. It would take billions of years for the universe to contract to the point of a singularity. But the effects would be catastrophic long before the final collapse. As the universe shrinks, galaxies would collide, stars would be ripped apart, and the very structure of atoms could be distorted. In the end, we would be left with a singularity, a point of infinite density where space and time have collapsed into nothingness. A state of existence so strange, so alien to our current understanding that it defies our comprehension. As mind-boggling as it sounds, the collapse of space and time could lead to scenarios that defy our understanding of reality. The implications of space and time collapsing are as fascinating as they are terrifying. Imagine a world where the laws of physics as we know them are disrupted, thrown into chaos. This is one possible outcome of a collapse in space and time. Physics is our way of making sense of the universe, a set of rules that govern how everything interacts. But what happens when the playing field itself changes? It's like playing chess on a board that's constantly shifting and warping. The pieces, the rules, they all remain the same, but the environment, the very fabric of the game, is in flux. Now let's take it a step further. Picture a black hole. These cosmic phenomena are areas where space and time are distorted so drastically that not even light can escape their gravitational pull. Some theories suggest that a collapse in space-time could lead to the creation of black holes. But these wouldn't be your average black holes. They could be gateways, doorways to entirely new universes, and this is where it gets really interesting. If a collapse in space and time could birth new universes, what does that mean for us? For our understanding of existence, it's a philosophical conundrum as much as it is a scientific one. Are we just one universe in a vast multiverse? Are there other versions of us out there living out their lives in parallel universes, birthed from the collapse of their own space-time? These questions may seem like they belong in the realm of science fiction, but in the face of a collapsing space-time, they become startlingly relevant. It's a thought experiment that challenges our understanding of reality, our place in the cosmos, and the very nature of existence itself. The collapse of space and time opens up a Pandora's box of possibilities, both thrilling and daunting. Our journey into the collapse of space and time has been a wild ride, hasn't it? We've delved deep into the enigma of these twin concepts, these invisible fabrics that hold our reality together. We've stepped into the realm of the abstract, where space is not just a void and time is not simply a ticking clock. We've probed the intricacies of these two elements, understanding their role in the grand scheme of the cosmos. We've learned that space is not merely emptiness between celestial bodies, but a dynamic entity that can bend, twist, and warp under the influence of mass and energy. Similarly, we've seen that time is not a constant stream, but a flexible dimension that can stretch and shrink, influenced by the curvature of space and the velocity of an observer. We've grappled with the mind-bending concept of the collapse of space and time, a scenario where reality as we know it might cease to exist, where the rules of physics could be rewritten, and where the very fabric of the universe could crumble. We've pondered over the implications of such a collapse, the effects it could have on everything from the smallest subatomic particles to the grandest galaxies. We've navigated through the complexities of this topic, but our exploration is far from over. There's so much more to discover, so many more questions to ask. The collapse of space and time, like many aspects of science, is a puzzle with countless pieces yet to be found and fit together. So continue this journey on your own. Probe deeper, question further, and let your curiosity guide you. The universe is a vast, fascinating place, full of wonders and mysteries waiting to be unveiled. If space and time ever do collapse, one thing is certain, it will be one heck of a show. Until then, keep questioning, keep exploring, and keep marveling at the wonders of the universe. Goodbye for now, and remember, the universe is full of mysteries waiting to be unveiled.